Hello everyone. In this video we are going to cover React in one comprehensive session. The goal is to cover all the fundamental React basics and important topics in a single video. First we will see how to set up a React application. Then we will look at the fundamental elements and building blocks of React. Moving forward, we will discuss core data flows such as how data is shared between elements and from a parent component to a child component. Next, we will cover rendering logic including conditional rendering and how to iterate over list in Reacts. Moving to advanced topic, we will look at the hooks in depth. Let's last but not the least, we will provide a conclusion and summary of all the top components or topics we have covered till now. To begin, let's talk about the prerequisites for your system. First, you must have Node.js installed on your system. If you have not, please download it from the web. Secondly, you need VS Code installed. If you don't have it, please watch the video linked in the I button and in the description to learn how to download the VS Code for your system. After downloading Node.js and VS Code, we will see how to set up a project. First, search for and open up your CMD. Then navigate to the directory where you want to store your React application. I will store mine in documents. I will navigate there and use the command mkdir to create a new folder called React application. This creates a new folder. Now we need to open this folder in VS Code. First, move into that directory using cd React application. Now that you are in the React application directory, you can open this folder in VS Code using the simple command code space dot. You will see the folder has opened. If you want to open the terminal, you can go to the terminal menu and click the new terminal. Alternatively, you can swipe up the terminal panel at the bottom of the window. Swiping up will reveal different panels including the terminal, which you can open from here. You can now create a React application here. The command to create a React application is npm create white at latest. This command will create a pre-built React application using white where all the npm dependencies are already pre-installed. First, you can give your project a name. I will call it frontend. Keep the package name the same but in the lowercase letters. We are going to use React and will use JavaScript and React JavaScript as React uses the JSX format to write code that resembles HTML. This process will install all the npm packages and dependencies for your project. Now you can see all the dependencies and packages are installed and your application is running on the port localhost 5173. To open that port, simply hold Ctrl and click on that link. It will open it in your native browser. Here it is. This is the front-end application running on localhost 5173. You can see some pre-built UIs there, including a counter. By clicking it, the counter will increase and upon refreshing it will reset to 0. Before we look at the files, an important note: if you want to stop the running React application, simply press Ctrl C on the terminal. If you want to rerun your React application, simply type npm run dev. First you need to be in the directory of your application. Since our application is named frontend, first move into that folder cd frontend. Now you are in your application directory. Run the command npm run dev. Your application will be running on the same port again. You can either click on that link again by control plus click, or go to the previous application link, or just refresh the page. Now we will see how the directories are structured and used. Whenever we run the React application, the index.html file is called first. This file includes everything like meta tags and the main structure. If you don't know about the head tags or boilerplate code of HTML, what is it, please go and watch the video given in the description, as I have explained it in my previous video. In the body section of index.html, you can see that we are calling the main.jsx file. If you go to the source folder, you can see the main.jsx file. When you open that file, you can see another component called app is called there. In the source folder, we have app.jsx, where everything visible on the React application is coded. If you want to delete the default content, you can. I am going to tell you the secret to quickly generate the boilerplate code of for any component in React. First, go to the extensions menu and download React snippets. This will install all the React shortcuts on your system. Then if you come back to the app.jsx and simply type RAFCE and hit enter, the component boilerplate code will be generated. Now we want to render an h1 tag in app.jsx that displays the text hello world. If I check the React application, hello world is written there. You might wonder why the text is centered and not starting from the top left corner. This is because if we look at the default CSS file, a lot of styling code is written there. We also need to delete the default code in index.css. Only need to add the basic CSS reset code, which is margin 0, padding 0 and box sizing as border box. This is the basic initialization code for every CSS file. It removes all the extra margins and padding from the web page. Now you can see our text is starting from the top left corner. With this setup complete, we will now move on the next topic. Project file walkthrough. So we have completed the introduction and tooling section, which covered the necessary tools like Node Package Manager, npm and VS Code. The next part is the project structure and walkthrough. How everything is structured in a React application. We see the source folder, which also contains assets. This is where file or images you want to present on your UI is located. We will see how to access the every image from the asset folder. You can also see .gitignore, which is used to ignore certain files when you upload your code to your GitHub account. Other files include the readme file, whiteconfig.js and package.json. The package.json file includes all the information about your React application, such as its name, status, version, and the script section, which defines the commands used to run your application. Next are the dependencies. Initially, we have React and React DOM. If we need any other in the future, we will install them. Then we have dev dependencies. So the difference is that whatever dependencies are needed to run the application on a local host server are called dev dependencies. The libraries or dependencies needed to create a build are very useful. A, a build is what you create when you are making your site live on a portal like Vercel or Render. This is the difference between dependencies and dev dependencies. Moving on, the package log JSON file. It is similar to the package.json but with more detailed information about your React application. Then we can see a public folder which includes most of the images for your React application. For example, if you want to change the title or the logo of your application, the logo should be in the public folder, so the React application can directly access it. If you check the index.html file, the link icon initially points to the white.svj file located in the public folder. Finally, we see the node modules folder, which includes thousands of libraries and dependencies that are necessary for your React application to run smoothly. Now moving to the next concept, components and JSX. So what is a component? A component is in React is essentially a function that returns HTML elements within JavaScript. To visualize what a component is, let's look at any complex website. For example, consider a site like GFG, Geeks for Geeks. Here you can see that every part of the page is built using separate components. The top navigation section is one component. The navbar, the left and right sidebars are different components, and the main middle area is another component. This is where the concept of virtual DOM becomes crucial. So, what is a virtual DOM? It creates a lightweight copy of the actual browser DOM document object model. The key benefit is efficiency. When changes are required for any single component, the browser only reloads or re-renders that specific component instead of reloading the entire application. For example, if the entire website were built as a single large HTML file and something changed in the navigation bar, the browser would have to reload and process the complete code again. This is unnecessary and very time consuming. The virtual DOM eliminates this problem, leading to much faster updates and better performance. Now, how the component is created, how it returns an HTML element from a function, and how it is rendered in a React application. Let's move to your React application. To create a component, go to source folder, create a new folder and name it components. Inside that components folder, create a new folder for your specific component, which we will call content. In every component folder, you need to initialize at least two files, the JSX file and the CSS file. We will name them content.jsx and content.css. Always, here's a note, always name your component with a capital letter. This makes it easier to handle import statements, and is the standard convention in React. First, let's open content.jsx and generate the boilerplate code by typing RAFCE and hitting enter. A simple functional component will be generated. Next, you need to import the CSS file at the top of the component by statement import dot slash content dot css. In the component function definition, you can pass the parameter which we call props in React inside the brackets. We will cover how to share the data. The return statement is where you define the output that the component will render. The return statement is where you define the output that the component will render. Let's create the component to be displayed. So first we define a React statement inside which we define a div class name as content container, inside which we will define a h1 tag with text hello welcome to the React. Now we are going to export the content. uh, After that, in the separate content.css file, you can design the dot content container class. While you can use inline css, it tends to make the content very cumbersome, lengthy, or difficult to manage and debug later. The best practice is to create a separate CSS file and import it into a JSX file, allowing you to centralize the styling for that component. Before rendering, let's quickly clarify JSX. JSX stands for JavaScript XML. The browser fundamentally understands JavaScript. In a JSX file, we are writing HTML-like code within JavaScript. When the React application runs, the JSX preprocessor converts that component code into plain JavaScript code that the browser can easily understand and use to render the component on the website. This is the main purpose of using the .jsx, the file format in React component. Now importing and rendering the component. So we have created the content component. Now we will see how to import and present it on our website. Go to the app.jsx file and delete the previous message. We want the app component to render the content component. Simply return the component as a custom tag content. When you type content in the return statement, the suggestion should appear, and hitting enter will automatically add the necessary import statement at the top. Import content from the file location. If you check your running application, the message should be updated. If the content is not visible, open your browser's developer tool either by right click or to go to the inspect method, or by Control Shift I buttons. Move to the console tab and check for any errors. If you see an error, correct the mistake in your JSX file. Once corrected, the content components output will be visible on your localhost. This is the fundamental process of how components are created, styled, and imported or exported in React. Now let's move on to the important topic of styling components. We have successfully created our content component and rendered the hello welcome to the React message. However, for any real world application, we need to make it look professional, which requires styling using CSS. Now applying styles in content.css. Let's use the class name we defined earlier, content, and apply some styles. Content.container h1 tag has properties like font defining. Now verification. Since we already added the import statement of css file in our jsx file, as soon as you save the css file, your running application should automatically update. You should now see the hello welcome to React text displayed within a style centered box. This method keeps your presentation logic separate from your structure and functionality logic, resulting in clean, organized, and easily maintainable code base. We have successfully styled our components and learned how to build the structure of our app. But a website that just looks good isn't enough. It needs to work and respond to the user. This is where the logic of React comes into play. Today we are focusing on how to manage data using something called hooks, especially the useState hook, and how to handle user inputs. In the first part of our coding demonstration, I defined a state for a username. The syntax looks like this: constant name set name is equal to useState Bunny Solankia. Let's break it down because it can look a bit stranger at first. The first item, name, is the variable that holds our current data. The second item, set name, is a special function that is only way we should ever update the data. We initialize it with the string Bunny Solankia inside the parentheses. Now look at how we use this in our JSX. Instead of hard coding the name into the h1 tag, we use curly braces and put the variable name inside. So our heading now reads hello welcome to the React name, curly braces name. Because of this, whatever value is currently stored in our state will automatically appear on the screen. If I were to change the initial value in the code to something else, you would see the website update instantly without us having to touch the HTML manually. Moving to the second part of the video, we wanted to make this truly interactive by allowing the user to type their own name. To handle this, I created a second state especially for our input box. I defined it as a constant input name. Set input name is equal to useState with empty string. Notice that I started this with an empty string because when the page first loads, the input box should be empty. To connect this to our UI, I added an input field below our welcome message. In React, we use what are called control components. This means the value of the input box is always driven by the state. So I set the value attribute to the input to curly braces input name. However, if you do this alone, you will find you can't type anything into the box. This is because React is forcing the value to stay as whatever is in the state, which is currently an empty string. To fix this, we need to handle the change event. This is where the handle change function comes into play. In the video you saw, we defined the function to capture what the user is typing. I added an onChange attribute to the input tag and linked it to this function. Let's talk about the logic inside handle change. The function receives an event object which we usually called E. This is of Think of this E as a messenger that contains all the details about what just happened. When you type a letter, that event is triggered inside the function. Inside the function, we call set input name parenthesis e dot target dot value. The e dot target refers to the input box itself, and dot value is the actual text currently sitting inside that box. The moment that state updates, react re-render the component. Because we also link the inputs value to the state, the text appears in the box smoothly as you type. Now as you watch the browser, you can see a live preview. Every single keystroke you make goes through the handle change function, updates the state, and immediately updates the text of the screen. Now that we are capturing the user's input in our input name state, we want to actually update the welcome message when they click the enter button. So to do this, we will create a new function called handle set username. The function performs two key tasks. First, update the permanent username. It takes the current value stored in the input name and pass it to the username set username. Then it clears the input field. So to provide a better user experience, we set input name back to an empty string, so the box is ready for a new entry. Then next we need to trigger this logic. We go down to our button element and button and add an on click event listener, passing it to our new function. It's helpful. Now visualize the data flow. So it's helpful to visualize how the data is moving through the component. Step A, the user types handle input change update input name in the real time. Then step B, the user clicks enter, handle set username is triggered. Then react re-render the component. The h1 tag now displays the new username, and the input box return to its in empty state because its value is tied to the non. Before we dive into the visual changes on the screen, let's talk about the backbone of our component, the useState hook. It is important to realize that state is not just for capturing text. In React, you can initialize state with any data type, whether it's a boolean for toggles or a number for counters, or even an array for list. This versatility is exactly what allows React to be so powerful. It tracks these values and knows exactly when to refresh the UI. Now let's focus on a key concept called conditional rendering. In our current setup, we don't want to welcome message to just sit there empty before the user has even typed their name. It looks unfinished. We want our application to make a decision. If a name exists, show the greeting. If not, show nothing. To achieve this, we use a ternary operator inside our JSX. Because we are inside the return statement, we wrap our logic in curly braces. The syntax follows a specific pattern: condition, expression if true, otherwise expression if false. In our code, we look at the username variable. If username has a value, the code after the question mark runs and React render the S component. However, if username is empty string, the code after the colon runs. In this case, we simply provide an empty string which tells React to render absolutely nothing to the screen. When you watch the application in action, you will see that the welcome message is completely absent. When the page first loads, it only snaps into existence the moment you click the enter button. Moving forward from the conditional rendering, let's explore one of the most important tools in a React developer toolkit: rendering list of data. While we previously worked with single strings, in real-world application you will often handle collections of information like a list of students, products, or messages. To keep our project organized, we begin by creating a new folder for our student component. Inside the component, we initialize our state using the useState hook, but this time, instead of a string, we pass in an array of objects. Each object represents a student containing properties like their ID, name, and grade. Before we build the table, we need to integrate this new component into our main application. When we move to the app.jsx to import the student component, we run into a common React scenario. We already have a content component here. There, since a React component can only return a single parent element, we can use React fragments. Fragments allow us to group multiple components together without adding unnecessary extra nodes to the HTML DOM, keeping our layout clean and efficient. Now inside the student.jsx file, we build the structure for a table. To display our 10 student without writing 10 separate rows manually, we use the map function. Think of map as a loop that transfer each item in our array into a piece of JSX. As we iterate through the list, we define a callback function where each individual student object is passed. A critical part of this process is the key prop. We assign key is equal to student.id inside curly braces to the top level element of the return row. This unique identifier is essential because it helps React track which item has changed, been added and been removed, which significantly boosts performance during updates. Inside each table row, we use the student object to fetch and display the data dynamically. Instead of hard coding values, we use curly braces student.name, student.age, or student.grades inside curly braces inside our table data TD cell. If you don't know about what is how to create the table in HTML, please watch my video given in the description. This creates a dynamic link between our data array and the UI. When you look at the final demo, you see a perfectly formatted table where every piece of data from our state is rendered accurately. This approach allows you to handle 10, 100 or even thousands items with the exact same amount of code. Now, in the next part, we are going to learn about hooks in React. We will discuss the three most commonly used hook: useState, useEffect, and useContext. Let's dive right in. Starting with the useState, this hook is used to define and manage the states within a React component. I discussed this in great detail in our previous part, so if you missed it, please go back and watch that video for more info. Just remember, whenever you need to store data that changes the UI, useState is your go-to tool. Now moving to the useEffect, to design to capture changes in the UI and handle side effects. As you can see in the code, it takes two parameters: the function call and the dependency array. For the function, you can either directly define an arrow function or call a predefined function like the function one in shown in the code. While calling a separate function is valid, it is used very rarely in the industry. So we will focus on the arrow function approach today. Now this is the most important part. There are three different ways to use the dependency array. Case 1, no dependency array. When no array is provided at all, the useEffect function is going to render again and again every time any changes happen on the UI. This can be heavy on performance. Case 2, empty dependency array. When an empty array is given, the function is called only once, specifically when the component is first mounted or loaded. This is the perfect for API calls. Case 3, permanent inside the array, like count inside the square bracket. When a specific parameter is placed inside the array, the hook will be called every time that specific parameter changes. In our code, you'll see that every time the count changes, your message is updated automatically. Now let's move to our third and very powerful hook, use context. In React, we usually pass data from a parent to a child component using props. But if we have many layers of component, passing props become messy. This is known as prop drilling. Use context allow us to create a global store so any component can access the data directly without needing props. So to keep our code organized, we don't define the context inside our main component. Instead, we create a separate folder named context, and inside it a file named context api.js. This is where our global logic will live. Inside this file, we first create our context using create context null. Then we define a component called context provider. Notice that we are moving the count and message states which were originally in our hooks component right into this provider. By doing this, these states become global. We then return the context api.provider. We pass an object containing our states and functions count, message, and set message into the value prop. Finally, we wrap props.children inside it so that any child we put inside the provider can access these values. Now let's see how to use these in our hooks.jsx file. First, we import the useContext hook from React and our context API. By using this single line, we are destructing the global states. Now, our buttons for increment or decrement will update the global count, and our useEffect will still capture those changes to update the message. And that wraps up our deep dive into React hooks. In this tutorial, I have tried my best to show a clean demo of each important concept, from managing state with useState to handling side effects with useEffect, and finally managing global data with useContext. I hope this made learning these concepts easy for you. If you have any doubts or get stuck anywhere, please feel free to ask in the comment section below. If you found this video helpful, please hit the like button and subscribe to the channel for more React content. Don't forget to share the video with your friends who are also learning web development. Thank you so much for your watching. I'll see you in the next video. Until then, keep learning, keep coding.